The other set of less important expansions is, rather than double, the triple angle results. Okay, so one of the results that's on, I think, the bottom of the first side of the sheet is for tan 3 theta. I think tan 3 theta. Okay, so how do you work out what tan 3 theta is in just terms of regular tans? Okay, it's not a particularly fun process. Some of you might have seen me do it yesterday. You just want to treat it as a regular expansion of theta and 2 theta. Okay? And it's going to become a little bit gross because these two are going to expand out into fractions again. Watch what happens. If I just treat this as my A and my B, okay, on the top of the tan A plus B expansion is tan A plus tan B. Tan A plus tan B. And then on the denominator, 1 minus the product, tan A, tan B, which is tan theta, tan 2 theta. Okay? Now to work with this thing, I'm going to have to expand again. Okay? Now I'm just going to finish this out because this draws out a helpful lesson for us. The expansion here is double angle. Tan theta plus tan theta, so 2 tan theta all over 1 minus tan squared. 1 minus tan theta, and same thing, except multiply. Okay. Now just to make my working simpler, I don't recommend that you do this. Though if you're trying to solve a question and it just feels like it's taking forever, like say a trig identity, okay, you can do this just to save yourself a bit of time, but maybe not present your answer like this. Everything here is tans. Okay, so I'm just going to say let tan theta equals, say, capital T. Okay, it's just going to be faster for me to write, that's all. Okay, so I've got T plus 2T on 1 minus T squared all over 1 minus T outside of the same thing. Okay, so what should I do to this fraction to simplify it a little? I want to get rid of these fractions on fractions probably, right? That's the easiest way to go. So I'm going to multiply everything, top and bottom, by 1 minus T squared. That'll eliminate my fractions. Can you see that? Not actually changing the fraction at all. So T times that is T minus T cubed. Yeah. This times our fraction eliminates the denominator. Okay. On the bottom, I'm going to have a 1 minus T squared there. This here, let's see what happens. You've got 2T squared times 1 minus T squared. Is that right? Sorry. No, not 1 minus T squared. That just cancelled from my fraction. Is that okay? Does that check out so far? Yeah. Let me get rid of that. Come up here. All I need to do is just gather like terms. So that's equal to 3T minus T cubed. And on the bottom here, I've got T squareds that go together. So I've got 1 minus 3T squared. And let's just fix that up in terms of what it actually means. So here is the triple angle identity for tan. Okay. Now again, just like with the half angle ones, you don't have to memorize this because it's not that useful, right? A typical example, have a look at the second side of the sheet. Where's the question? It's somewhere in the middle. I can't remember what number it is. But there's a question which has a triple angle in it. Can you see it? It's like tan squared. 7B. Yeah, that's right. That sounds familiar. Tan squared 3 alpha is equal to a third, I think. Is that right?
Yeah.
Yeah. Okay, now, having proved this, you might think, oh, well, I'm in trig expansions, so I better use, oh, sorry, I forgot domain, by the way. I should use my trig expansions for this question, right? So if I give that a go, what's going to happen? Well, I've got, what is my identity? I've got 3 tan theta minus tan cubed, I should make this bigger, all over 1 minus 3 tan squared, and that's squared, and that's equal to a third, right? So you're like, what shall I do here? Well, it's all squared, right? So you're like, I guess that means that's 9 tan squared theta minus 6 tan 4 theta plus tan 6 theta all over 1 minus 6 tan squared theta plus 9 tan to the 4 theta equals a third. And at this point, blood starts to stream out of your ears because your brain is melting, okay? This is solvable, but you'll probably be dead by the end of it, okay? So what should you do instead? Triple angle is not the best way to approach this. Instead, you should rewind and say, well, okay, I'm going to solve this, right? But for not alpha, but for 3 alpha, right? So how does it work? If that's my domain for alpha, then my domain for 3 alpha will be, I just multiply the whole thing by 3, right? So it'll be 1080. Okay, so how does this affect us as we go on? I'm just going to keep on marching through without worrying about what the alphas will be. They'll come out later. So if I take the square root, I've got plus or minus 1 on root 3. Okay, so that's going to be 30 degrees. That's our base angle. Yeah, 30 degrees. Since I'm plus or minus, I'm in all the quadrants. Yes? So 3 alpha will be 30 degrees. The next one is 180 minus 30 degrees. The next one is 180 plus 30 degrees. The next one is 360 minus. Now at this point you would usually stop, except we're in terms of 3 alpha, and your domain keeps on going way past 360, right? So I shouldn't just get my regular 4 answers. This domain is 3 times larger, so I should expect 3 times as many answers, okay? Now, relax, even though you're like, far out, there's so many. It's very easy to get what they are, because just all of these plus 360. And all of these plus, let's see. Then I have to add 720 to get to the next lot, right? So let's see here, 750. 930 and 1050. Okay, 12 answers, because that's how long my domain is. But then, of course, I actually want alpha, right? So just divide everything by 3. 10, 50, 70, 110. You can keep going from here, right? So I'm going to have all 12 of my answers. But that was, I mean, it looks terrible, but you were going to get those 12 answers anyway if you solved that awful nosebleed thing earlier, right? And at least this, the number's actually quite simple, okay? So this is why triple angle results, usually when they appear, there's better ways to deal with them. Triple angle doesn't tend to actually make things much better, often makes it worse, okay? So that's why, should I memorize triple angle results? No, okay? I mean, sometimes they'll appear just to show that you can go through solving a trig identity, but you wouldn't actually use them to solve questions. Okay, does that make sense?